Hello students, in the previous video we studied what is finite automata, what is the mathematical definition of finite automata and the block diagram of finite automata. In this video we will study how to represent a finite automata or the transition function. There are two methods for representing finite automata. First one is transition diagram and the second one is transition table. First we discuss how to represent a finite automata using transition diagram. Suppose we have a finite automata ms equal to q sigma delta q0f. How can we represent this finite automata using transition diagram? Transition diagram is actually a directed graph. So graph means it has number of vertices and edges. So vertex of the graph is the states in the given automata. Suppose we have two states P and Q. Then these two states are represented by the nodes of the graph. Nodes are usually drawn as circle, states within the circle. Okay. Then if there is a transition delta of P comma A is equal to Q. That means from the state P, the automata reads the input symbol A, it goes to the state Q. That means there is a transition from state P to state Q over the alphabet A. This is represented by a directed labeled arrow. Okay, directed labeled edge labeled by A. Directed edge labeled by A. There is a transition from P to Q over the alphabet A. Okay. Then how can we represent the initial state? Initial state is represented by an arrow pointing to the initial state. Suppose P is the initial state of this automata, then we draw an arrow pointing to this initial state. Okay. Then how can we represent the final state? Suppose Q is the final state. Final state is always within two circles or double circles. Single circle means a normal state and double circle, state within double circle means it is a final state. Another point is, suppose delta of P comma A is equal to Q and also delta of P comma B is equal to Q itself. That means from the state P, it goes to the state Q if the input symbol is A or B. In this case, we represent it as edges labeled by both A and B. That means A comma B. There is a transition from P to Q over the alphabet both A and B. Clear? These are all about the transition diagram. It is represented as a directed graph. So each state in Q there is a node. Then for each state in Q and each input symbol A in sigma, if delta of P comma A is equal to Q, then there is a directed arc from P to Q labeled by A. If there are several transitions from P to Q over the from P to Q, then it is represented by a directed arrow from P to Q labeled by the input symbols separated by commas. Then initial state is represented by the arrow to the initial state and final state by double circles. Okay. So consider this diagram. Give the transition diagram. For the given transition diagram, find the quintuple. We have to find out what is M. Okay, what is M? M is equal to, M is equal to Q sigma delta Q0F. Q sigma delta Q0F. So we have to find out each of the 5 values. what is Q? So in the given diagram, what is Q? Q is equal to, how many states are there? How many vertex in the graph? Two vertices, Q0 and Q1. So that are the states of the given transition diagram. So Q0, Q1 are the states. So it is a finite set, put within, return the states within the sets. Okay, that is Q. Then next is, what is sigma? Sigma is equal to set what are the input symbols in the given graph, given transition diagram? 0 and 1. So here set 0 and 1, two input symbols only. So the finite set of input symbols is called alphabet. Sigma is equal to set 0, 1. Then delta, we have to write each delta. Before that, we can write what is Q0. Q0 means the initial state. Okay, Q0 is the initial state. Q0 is equal to, in this state, Q0 is the initial state. So in the given transition diagram, Q0 itself is the initial state. So we can write it as Q0 is equal to Q0. Then next we have to find out what is F. F is the finite set of final states. So we have to write the final state within set. So here only one final state, Q0. So we can write set Q0 is the final state. Okay. Then what is the delta? So we have to write all the delta transitions. That is delta of, first transition is from the state Q0, it reads the input symbol 0. From the Q0, it goes to Q0 itself. Then from the state Q0, it reads the input symbol Q1, it goes to Q1. From the state Q1, it reads the input symbol Q0, it goes to Q0. From the state Q1, it reads the input symbol Q1 and it goes to Q1 itself. So we should write all the 4 transitions. That is Q0, 0 is equal to Q0 itself. Okay. Next one is delta of Q0, 1. Q0, 1 is equal to Q1. Next is delta of Q1, 0. Q1, 0 is equal to Q0. The next one is delta of Q1, 1. Q1, 1 is equal to Q1 itself. So these are the different transitions in the given diagram. Okay, so we write the quintuple. Okay, quintuple M is equal to set Q0, Q1, set 0, 1, delta Q0, then F is equal to set Q0. So this is our M machine. Okay. Next method is transition table. How can we represent a finite automata using transition table? So we can take the previous example. Here is our previous example. Okay, how can we represent this finite automata using transition table? Transition table is a tabular representation. That means there are number of rows and columns are there. Rows represents the states and columns represents the inputs. Okay, so here there are two states. Okay, so there are two rows, q0, q1, two rows are there. Okay, then columns represents the inputs. Okay, so here we can draw the column. Okay, so this is the two rows, and here we have two columns because here there are two inputs, 0 and 1. So we have two simples, 0 and 1. So here we have two simples. Then each entry in the table, how can we represent each entry? Each entry in the table represents, if there is a transition from q0 to 0, so this entry represents, okay, this entry represents the q0, row q0 and column 0. That means if there is a, this entry means delta of q0 comma 0. Okay, entry corresponding to the row q0 and column 0 means it is the value of delta of q0 comma 0. Okay, so we know delta of q0 comma 0, delta of q0 comma 0 is equal to q0. Then delta of q0 comma 1 is equal to q1. Then delta of q1 comma 0 is equal to q0, and q1 comma 1 is equal to q1. So this is our transition table. Okay, okay, q0 means delta of q0 comma 0, q0 comma 0, q0 itself, q0 comma 1, delta of q0 comma 1, q1, q1 comma 0, q0, q1 comma 1, q1. Okay, so each entry corresponds to the state q and input symbol a. That means this entry is equal to delta of q0 comma 0. This entry is equal to delta of q0 comma 1. This entry is equal to delta of q1 comma 0. This entry is equal to delta of q1 comma 1. Then next we have to mark the initial state and the final state. Initial state is marked as an arrow towards the state like this. Then final state, we can mark final state in two ways. Put a star symbol, here q0 itself is the initial is a final state. So we can put a circle, we can circle the state to indicate it as a final state, or you can mark star symbol before the state. Both represents the final state. Okay, encircle the state or put a star mark before the state represents it as a final state. So this is the transition table for this transition diagram. Okay, so tabular representation, transition table representation of finite automata means it is a tabular representation. There are number of rows and columns. Rows represents the states and columns represents the input symbol. Okay, then each entry in the table, this entry in the table represents the state from the state q0, from the state q, generally we can say that from the state q and the input symbol a, then delta of q comma a is entered in this entry. Okay, then initial state is marked as, put an arrow towards the state, initial state, and final state, we can represent final state in two ways. Put a star mark before the state or circle the state. Okay, so this is the transition table. So these are the two methods for representing finite automata or transition diagram. Okay, thank you.